Welcome to my YouTube channel. Kindly subscribe and share the videos also so that many students can get the benefit. Today we are moving towards International IGCSE Physics. Uh, Section 3 topic is related to waves over there. Waves is basically a phenomenon in which we can say energy is transferred away from its source over there. For example, here I am taking a water tub over there, which is filled with water. And if I give a disturbance at its center, I am giving a disturbance at its center, what will happen? It will start to move away from its source. And this energy in the form of disturbance is moving towards the banks of this container over there. Then we can say it is called wave motion over there. And we will talk about its waves phenomenon, which will have the terms that will be related to its basic types. So wave motion, first of all, wave motion, it is the transfer of energy or transfer of disturbance away from its source, away, transfer of disturbance away from its source point, from its source towards the banks of container, towards the banks of container is called wave motion. In wave motion phenomenon, energy transfers only, but matter does not. Matter stays at same position. Like water, I said here, matter stays at same position. It does not leave its position at all. After that, the main key terms which I will use about the waves, I know that all waves have wavelength, all waves have frequency, all waves have amplitude and speed also over there. I will move towards them, but before going towards these key terms which will be used in explaining waves, I will go first towards types of waves. Types of waves. There are basically two main types of waves. One is related to mechanical waves, and the second one is related to electromagnetic waves over there. Electromagnetic waves, EM waves, we can say here. Waves. Mechanical waves are those which require medium for their propagation. For example, I am talking and you are listening, my sound over there, then it is requiring air because the disturbance caused or in the form of vibration caused in the air is going to exactly follow that disturbance in the air, and it is striking with the eardrum, and auditory nerve is getting that message, and your voice is being detected, and you are understanding what I am saying basically there. Those are called mechanical waves, and which don't require medium for their propagation are called electromagnetic waves over there. No medium is required by electromagnetic waves there. And mechanical waves which require medium, we can say that is a sound wave, that can be water waves, that can be also waves in a string over there, And in case of electromagnetic waves, which don't require any medium for their propagation, I can say that is light, that is having X-rays there, which don't require any medium for their propagation over there. And we can say here that waves, which are mechanical waves, basically, I can say about them that these are those waves which are requiring medium. They have two main types of them that can we say about their basic types over there. If I am going to discuss them, then I will say here about mechanical waves that they have two main types. Those are called mechanical waves are having the types transverse waves, transverse waves. Transverse waves are those if there is a medium line is this and the wave is propagating in this way means the waves which propagate perpendicular to the particles of medium are called transverse waves. And the upper peaks, which are highlighted with the letters A and B, are called crus. Upper peaks are called crus over there. And the lower peaks, which are named with letters C and D, are there below the medium line. Those highlighted points C and D are called crus of medium over there. And these crus and troughs, this will be trough. Wait a second, I have written the wrong way over there. Trough over there. I should write here trough, not crust over there. I should write there. These are the troughs. These are called troughs. Oughs. These are called troughs. Now, and the example, if I want to highlight there, these can be electromagnetic waves. These can be water waves. These can be waves in a string. If I want to define my terminologies, which we have mostly used with the phenomenon of waves over there, that is called basically, let's go for, first of all, towards wavelength. Wavelength means length of a wave, represented by symbol lambda, measured in meters, and we can say distance between two consecutive crus R troughs. You can take A from A to B distance. You can take R C to D distance. Over there, that is called wavelength. After that, there is frequency. Frequency. Frequency is basically number of waves passing through a point in 1 second. Number of waves passing through a point in 1 second is called frequency, and it is measured in S-1 per second, or Hertz as SI base unit over there, HERTZ, Hertz. And it is directly to relate with the time period also. If I will relate, wait a second, time period. Time required by a wave, time required by a wave, or time taken for one complete wave to pass a point. Time required for one wave to pass through a point. Pass through a point. Remember that for wavelength, I am using the symbol lambda. For frequency, I am using the letter small f. For time period, I am using capital letter T here. And now this is measured in second time period. And if I relate both frequency and time period, then they are reciprocal of each other. F is equal to 1 over T over there. Mostly time is given in milliseconds, then we will have to take milli as a prefixes over there to convert to get that value exactly over there. After that, time period, frequency, wavelength, I will say there is amplitude. Amplitude. Amplitude is basically the distance between the medium line to the maximum height, or we can say the height of a wave from rest to the crest. The height of a wave, from medium line or rest line to the crest, This is the maximum distance. Maximum distance from mean position to crest over there is called amplitude, measured in meters over there, can be taken positive in case of crest and can be taken as negative in case of trough over there. And this displacement can also be taken if you are taking at any point on the wave from the mean line, then you use the word displacement over there. Displacement or instantaneous displacement means at any point on wave, what we use the distance from mean position to the distance at any point on wave, the distance from mean position. It is called displacement of that wave over there. Then if we go for the speed of the wave or velocity of the wave, it will tell us how fast the wave is going on. For that speed phenomenon, I will say here speed of wave. It tells how fast the wave is going on. Is passing through that point. If I relate my speed, frequency, and wavelength in a proper relationship, then I use a formula V is equal to F multiply lambda over there. So this is the way in the triangle form. If I want to write it, then I can say it is V multiply lambda F. V is equal to F lambda can be taken into account over there. And we can use this relation in the form of wave calculation over there. So after if we are moving towards after transverse waves, if I am moving towards the second type, when I say it should follow through parallel way, then I say that is longitudinal. longitudinal waves. Longitudinal waves are basically those waves, the waves which propagate, which flow, which propagate parallel to the particles of medium, to the particles of medium, particles of medium are called longitudinal waves. Waves over there. So longitudinal waves, we can say the longitudinal waves are given in the form of example. Then these are sound waves. These are, we can say, ultrasound. Ultrasound waves. These can be in the form of shock waves. We can say seismic waves over there. Shock waves also can be taken as shock waves, which are in the form of earthquake like that. Seismic waves, seismic waves, SIESMIC, seismic waves. And if I take the spring over there to become pushed and pulled over there, then they are also called in the form of longitudinal waves. If I am going to explain like crust and trough, what will be the here scenario over there, then I will say they are going to follow the pattern of compression and then rarefaction, then compression, and then rarefaction, then compression, and then rarefaction. So this will be the phenomenon how the sound wave is propagating from compression, 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 and this is rarefaction, rarefaction, rarefaction. Compression are those points where the wave is compressed and the sound or something is being going to disturbance over medium. On the other end, there is a rare fraction where the medium particles are little bit relaxed to show the zero amplitude over there can be taken. In longitudinal waves, the vibration are along the same direction as the wave transfer the energy over there. So all the waves basically transfer energy and information without transferring matter. Remember some key points about waves. All waves carry and transfer energy in the direction they are traveling. Like microwaves in an oven make things warm up. Their energy is transferred to food for cooking purpose. Sound waves can make things to vibrate or move, like loud bangs over there can start avalanches over there. After that, waves can also be used as signals to transfer information. So here I will say waves transfer energy in the direction of their travel. Waves transfer information in the form of signals over there without transferring energy from one place to another, like light in an optical fiber. For information, we can say light signal in optical fibers. Fibers over there can be taken into account. After that, if I move towards wave behavior in the form of electromagnetic waves, then how should we take the electromagnetic waves, which I was saying don't require any medium for their propagation over there? Then I can say the properties you see on the last page, you can affect last section over here, how waves behave over there. And there are one type of wave which very different properties at different wavelengths. We can call them electromagnetic waves. Here I will introduce you with a phenomenon of wave front over there. Like what is wave front? Wavefront basically an imaginary line which can become a source for the next wave to be shown on your screen or on your medium over there. Often when we talk about waves approaching an obstacle or boundary, there are multiple waves moving together in same direction. Then we can say, in case it is very useful to talk about wavefront. Wavefronts are imaginary planes. These are imaginary planes. These are imaginary planes. Um, these are imaginary planes that cut across. We can say that can cut across um, all the waves, all the waves by connecting the points on adjacent wave, by connecting the points on adjacent waves, which are vibrating together, which are vibrating together. These are called wave fronts or imaginary lines over there. For this one phenomenon of wavefront, the distance between each wavefront is equal to one wavelength. For example, here I am saying, this is my source. This is first imaginary line. This is the second imaginary line. This is, then I can also take a third imaginary line also there. Then I can say distance between first imaginary line wavefront to second imaginary wavefront line is equal to wavelength, is equal to lambda over there. And each wavefront is at the same point in the cycle, in the circle over there. And this is free body diagram. I am not using proper compass over there, so circle can be not equidistant from all the points. So you can use it by drawing proper in the form of compass in an exact circle over there. You can take in the form of electromagnetic waves to show. After that, there is Doppler effect waves make waves longer and shorter over there. Doppler effect basically states that the apparent change in frequency, apparent change in frequency due to a relative motion of source of sound of that which is producing that source and observer. That is called Doppler effect. And this Doppler effect, the waves produced by the source, which are moving towards or away from observer, will have different wavelengths than they would be the source were the stationary. This is because the wave speed is constant. Always remember that wave speed is constant there. And if the source is moving, it catches up to the waves in front of it. This causes the wave fronts to bunch up in front of moving source and spread out behind it. The frequency of a wave from a source moving towards you will be higher. Remember that speed is constant. Number two, if sources of sound is approaching a stationary observer, then frequency increases and wavelength decreases over there. If wavelength decreases, the frequency of a source towards will be higher, wavelength will be shorter than the wave produced of the source, and the frequency of the wave from the source moving away will be vice versa. Speed is constant, and if frequency is for moving away decreases, then we can say wavelength increases over there. So this is basically Doppler effect behind it. And faster the wave is moving away from you, the longer its wavelength will be. So that is basically, we can say, Doppler effect, which can make the wavelength and frequencies to change, and they show the phenomenon of your main formula of V is equal to F lambda over there. After that, there are basically 7 types of electromagnetic waves over there. Electromagnetic waves with different wavelengths have different properties. They are grouped into the 7 types depending upon their wavelength over there. Then I am roughly trying this sketch of 7 types of those waves over there. For example, first one is radio wave. Second one is microwaves. Third one is light. We can say here which we have to take the radio waves, microwaves, and then red and violet light till there. Red light, white light, and red light, white light, and I am taking here violet color is being taken. Then X-rays and gamma rays. X-rays, and at the last, I'm taking gamma rays over there. If I talk about them, radio waves has maximum wavelength, minimum frequency. And if I take this whole pattern to move on here, I will say wavelength minimum, that is going on to decrease, and frequency is going to increase on there, and it is maximum at that point over there. And energy is directly proportional to frequency. So energy for gamma rays will be maximum. And if I take after red light or even radio, that case, the speed of these waves will be equal to speed of light, that is 3 multiplied 10 raised to power 8 meter per second will be the speed of all of these waves over there. So all types of electromagnetic radiations are basically transverse waves, and they propagate perpendicular to the particles of the medium, and they travel at same speed through free space, a vacuum, and the different colors of visible light depend on wavelength. Red has the longest wavelength and lowest frequency, as shown in the case of red, white, and violet. It is having the minimum wavelength in white light, and it is having the maximum. Red is having maximum wavelength, minimum frequency. Violet is having, we can say, violet is having a minimum wavelength and maximum frequency or energy over there. So we can also say there that wavelengths is also being taken in the form of vice versa phenomenon over there. If I talk about the uses of electromagnetic waves, we can simply say their main use is being used for mainly used for communication purposes. Communication purposes in our mobile phone, in our internet, everywhere electromagnetic waves are used, like radio waves, like FM radiations with the wavelength of longer about 10 centimeter, and long wave radio like AM and FM, like radio waves, they can be used as radio waves in both cases of FM radio and AM radio. AM radio over there, both can be used for short wave and long wave over there. And radio waves used for TV and FM radio broadcasting have very short wavelength. And to get the reception, you might have the direct side of the transmitter, and signal does not bend around the hills over there. So they can also be used for TV, they can use for radio. All the signals can be calculated for the communication purposes over there. After that, there is after radio waves, there are microwaves. Microwaves have the wavelength around 1 to 10 centimeter. It is having 1 to 10 centimeter as its wavelength over there, and can also be used for communication like satellite communication with the TV signals and satellite phones over there. We can say microwaves. Microwaves can be used for satellite communication. SATELLITE, satellite communication. That can be done for TV signal, and satellite phones uses microphones. And for the satellite TV signals from a transmitter is transmitted into space, where it is picked up by the satellite receiver dish orbiting thousands of kilometers above the Earth. And the satellite transmits the signal back to the Earth, where it is received by satellite dish on the ground over there. Mobile phones are using the same microwaves over there. Microwaves are also being used for cooking purposes over there. That they are directed for cooking to be done in our homes over there. Microwaves can also be used for that phenomenon, where microwaves are absorbed by the water molecules in the food, and they penetrate a few centimeters into the food before being absorbed, and the energy is then conducted or convected. Conductor can also be used, and convection can also be used to the parts, to other parts over there. After that, there is IR, infrared radiations use. IR. Infrared radiations basically is also known as heat radiation. Heat radiation over there. This type of infrared radiation, we can say electrical heaters reduce, like as in winter season for making our homes hot, we are using heater over there. And it is evolving infrared radiation. It is releasing infrared radiations, and things like grills use infrared radiation to cook food. Infrared radiation is given out by all objects, hotter objects, like you have put a cup of tea at your table. What will happen? Infrared radiations are emitting heat, and the tea is getting cooled down. Infrared radiation given out by objects can be detected in the dark night by a night vision equipment, and the equipment turns it into an electrical signal, which is displayed on the screen and as a picture, allowing the things which would otherwise be hidden in the dark. Criminals on the run can also be seen by using this infrared radiation phenomenon over there. After that, light signals can pass through the optical fibers. Light signals, the next step which is being taken, that the light signals can be used in optical fibers, like our internet. Now I am talking about that. Optical fibers. Optical fibers are basically are using to look at the things around us. Visible light can be used for communication using optical fibers, which carry data over a long distances as pulses of light. They use as pulses of light for data over there to be transferred from one point to another at very long distances over there. After that, we can also say here that optical fibers work by bouncing waves off the sides of narrow core. Like optical fiber mode structure, if we go towards the optical fiber structure in detail, Then we know that there is optical fiber is having core, optical fiber is having cladding and jacket. Core and cladding are of different refractive index, having plastic made up of plastic or transparent material, proper ducts over there, which are conocentric, and they are helping the data to transfer from one point to another. And optical fibers are increasingly being used for telephone and internet over there. This optical fiber is being used for telephone and internet. They are also used for medical purpose to see inside the body without having to operate. We are using the optical fiber technology to use for them. And visible light is also useful for photography over there. If you want to take picture of some object, then we can say visible light. Visible light is required for photography over there. Photography purpose over there. We will have to use photograph for photography purpose. We will have to, we can say, use the visible light. Like cameras use a lens to focus the visible light onto a light sensitive film or sensor, and the lens aperture controls how much light enters the camera, and the shutter speed determines how long the film or sensor is exposed to the light. And by varying the aperture and shutter speed, a photographer can capture a picture as much as little light as they want in their photographs over there. So remember that only the photography phenomenon is using the visible light over there. After that, there is ultraviolet radiations, UV. Ultraviolet radiations are present. These are used for in the fluorescent lamps over there. Fluorescent lamps over there. And basically, what is fluorescence? Like fluorescent lamp, I said. Fluorescence is the property of certain chemicals which where ultraviolet radiation is absorbed and visible light is emitted. That's why the fluorescent colors look so bright. They actually emit light over there. Here I will say that ultraviolet radiations are absorbed. Such chemicals or materials where UV is absorbed and visible light emits, to make them more bright by use of ultraviolet radiations over there. Fluorescent lights are use UV radiations to emit visible light, and they are safe to use as nearly all the UV radiation is absorbed by the phosphor coating on inside of the glasses, which emits the visible light instead. So I am getting to the point. If you are focusing what I want to explain with these types of electromagnetic radiations with their uses, I think so you are getting my points and explanations over there. After that, after UV, I will move towards X-rays. You are much more familiar in according to medical point of view that bony parts, X-ray is used to observe the internal structure of the objects and materials, including our bodies, that they are so much useful in medicine. To make X-ray image, X-rays are directed towards the object of body and to detect plate over there, where they will make the, we can say, there will be X-ray paper over there. And when the rays are not absorbed, then they will not go for the blackening of X-ray paper over there. And those points where bones are available for human case over there, then what will happen? Those points where the bones are available are some hard material which is absorbing the X-ray, not allowing to pass through the body, will give you the light stance over X-ray photograph over there. And radiographers in hospital take X-ray photograph to help the doctors to diagnose the broken bones. X-rays pass easily through the flesh and denser material like bone or metal. They give the white color on X-ray paper over there. That is X-ray sheet, X-ray image making sheet over there. And exposure of X-ray can cause mutation. If you are going on daily basis to X-ray to be done, then it can be also dangerous, which can lead to a disease called bone cancer or simply cancer can be caused because of too much use of X-ray towards the medicine over there. After that, the last one is gamma radiations. Gamma rays or gamma radiations, I will say these are used to sterilize the medical equipments, like the medicine sterilize the equipments, like mostly which are by use for heart surgery or for brain surgery. Those are very delicate organs. So neurosurgeon and heart surgeon sterilize their equipments by using gamma rays over there. And sterilizing food is also being given to the high profile personalities in every country. Sterilize the instruments and sterilize the food over there can also be checked for both of these purposes. To use electromagnetic waves should be taken into account over there. So if I go to their some electromagnetic radiations dangers or losses over there, then I will say if I move towards now, I am moving towards dangers of these electromagnetic waves over there. Dangers of electromagnetic radiations. If I talk about them, then we can say that microwaves have a similar frequency of vibration of many molecules. So if I go one by one, then I'm say when electromagnetic radiations enter living tissues, like a human, it is often harmless, but sometimes it is creates a havoc. Some electromagnetic radiations mostly passes through soft tissue without being absorbed like wide radio waves. Radio waves which can pass through the body without harming over there. But some other types of radiations are absorbed and cause heating of the cells like microwaves. Microwaves, they are absorbed. And it can be dangerous for living body. Some radiations can cause serious changes in living cells like gamma radiations. Gamma rays can destroy my basic cells and cause the mutation over there and can cause cancer also over there. And the effect of electromagnetic radiations depend on its frequency. Frequency is mainly playing main role for danger for any human being over there. The higher the frequency of electromagnetic radiation, more energy it is, generally more harmful. Like frequency is much, much higher, energy will be higher, then it is very much harmful. Even though I am using X-ray, I'm using gamma rays, then it can be dangerous for living body over there. And in general, the waves with lower frequencies, which are harmless as far as we know, are less harmful than the frequency like X-rays or gamma rays. And from a safety point of view, if it is how the radiations affects the human tissues, that is the most vital, and you need to be affected towards this phenomenon. We will have to must take care about this phenomenon of organization over there. So this was related to our basic topic related to waves. Tomorrow I will start towards the reflection, the refraction, and diffraction phenomenon of light. Okay, basically, I will go towards light waves, towards the explanation of them. In reflection, we will talk mirror. In refraction, we will talk about lenses. In diffraction, we will only talk about bending of waves in the form of prism to be taken into account over there. And we will go towards critical angle. And then in the last, we will go also towards the sound waves to be explained over there. So try to be connected and follow up to the next video or for the preparation of complete topic of waves. Thank you so much for today. And this was our today class. It was too much lengthy, little bit, but it was good to teach you all in this way. Kindly subscribe my channel and stay blessed. Thank you so much. Allah Hafiz.